Hi there and welcome to Mr. T's Maths. In this video, I'll be showing you how to find expressions for the velocity and acceleration of a particle. So let's consider a particle moving in a straight line that produces the following displacement time graph. Okay. Now, if you were to work out the gradient of this line, using differentiation, then that would give you ds dt, which is the change of displacement over time. Now, change of displacement over time is actually velocity. So if we differentiate a displacement function, that gives us a function for the velocity. Similarly, if we look at the second graph, if we have a velocity time graph and we want to work out the gradient of the line, using differentiation, dv dt is actually the change in velocity with respect to time. But the change of velocity with respect to time is nothing less but acceleration. So in conclusion, if we are given a displacement function, and we differentiate, we end up with ds dt, which is actually the velocity. And if we differentiate that further, we find dv dt, which is the acceleration. So this is how you can find expressions for velocity and acceleration given a displacement function. So here is an example where a bicycle travels along a straight line. We are given its displacement in meters from its starting point, and that is 4t plus 3t squared minus t cubed. After a time of 2 seconds, find the bicycle's velocity. So first we want to find the bicycle's velocity. We are not told to differentiate or anything like that, but we should know, we should be able to deduce that in order to find the velocity, we have to differentiate this function that we are given for the displacement. So ds dt is equal to velocity, which is actually, in this case, let's differentiate this. 4t, we multiply by the power and subtract 1 from the power. So the derivative of 4t is 4 plus 6t minus 3t squared. So that's the velocity, and velocity is measured in meters per second, and it's in the direction from the starting point, so moving away from the starting point. Now we don't just want the velocity, we want the velocity after 2 seconds, which means that we want the velocity when t equals 2. So at t equals 2, the velocity is 4 plus 6 times 2 minus 3 times 2 squared, and that is 4 meters per second. So velocity is 4 meters per second. So here we've used differentiation, starting from a displacement function to find the velocity at a given time. In part B, we want to find the acceleration after a time of 2 seconds. Alright, so acceleration is actually the derivative of the velocity, the change in velocity with respect to time. So that is the derivative of the velocity function, which I'm going to write here again. That's 4 plus 6t minus 3t squared. So we have to find the derivative of that. So it's 6 minus 6t. Perfect. And this is acceleration, so it's meters per second squared. right? But we are interested to find it at t equals 2. So therefore acceleration equals to 6 minus 6 times 2. So we simply substitute t equals 2 in the acceleration function that we found. So the answer is, we will see negative minus 6 meters per second square. Now, can we have a negative answer? Yes, we can, because this is we are talking about acceleration, and acceleration is a vector. So the minus there is showing that this bicycle is actually slowing down. Yeah. So let's write this down. And this is how we can find the velocity and the acceleration at a given time using differentiation. In the following example, a pebble is thrown vertically upwards such that its height s meters above the top of the cliff after 30 seconds is given by this function over here. Find the maximum height. Okay, that's a keyword there. Maximum height reached by the pebble, and when. Okay, and we want to know also when this occurs. Okay, so as I always say with word problems, draw a sketch. Yeah, draw a sketch. So let's see. Here is the cliff. Okay, here is little Johnny standing here next to the cliff, and he decides to throw a pebble vertically up. Yeah, so the motion, the motion here is modeled. If you can see the trajectory of the pebble is like a parabola, upside down parabola, right? That's why, well, we have a quadratic function here. Yeah, so if we want to find that maximum height, we want to find this point here where actually the gradient is 0. So ds dt equals to 0. ds dt equals 0 over there. Okay, so let's see how we can do that. First of all, we want to find, as we said, ds dt. Okay, so we differentiate the displacement. That's actually velocity, so that when the maximum height is when the velocity will reach actually 0, because this will leave the hand, it goes up, it slows down, it reaches 0, it stops gaining velocity, and then it just starts falling down. So that is 10 minus 5 times 2, 10 t. Okay, but we just said that this happens when velocity equals 0, therefore 10 minus 10t equals to 0. So that's how we can find when does this take place. Okay, so 10 equals 10t, and therefore t equals 1. Okay, so at t equals 1 second, right, we have the maximum height. Now the question is, what is the maximum height? So we still have to find that maximum height. Yeah, so the maximum height, or in this case the displacement, this maximum displacement S max, okay, is given by this function here. This displacement function, sorry, my bad, the displacement function with t equals, when t equals 1. So 10 times 1 minus 5 times 1 squared. Okay, and that leaves us with actually 5 meters. So we've actually found that the maximum height reached by the pebble is 5 meters. Yeah, so the maximum height there is 5 meters, and that happens after 1 second. being thrown. Yeah. Well, I hope you found these examples useful, and remember that when differentiating the displacement, you end up with the velocity, and when differentiating the velocity, you gain acceleration. Okay. All right, this is the end. Take care.